All right, solve a system of inequalities. You got to come up with the equation. It looks like rise over run. Remember, it's down 2 and over 1. This has negative slope, so y is, it's shaded above this line, so it must be greater than. The reason I know it's greater than is because it's dotted, and the slope is negative because of the direction it's going. So let's go with negative 2x minus 1. Now I got to do this line right here. So now I'm going to come up with an equation for this red line right here. It's solid, so it's going to be below. So y is less than or equal to, again, the slope is up 1 and over 1, up 1 and over, so that's a positive x. And then it's at, the y-intercept is minus 4. So this area right here is above this line. That's the greater than, below the red line. Now I got to get this one in here. So it looks like this one in here will be, again, a greater than or less than, and since the area is above it, just count negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, so y is greater than negative 6. And then this, that's the green line. This is the black line. This black line right here. So the area that's to the right, I'm sorry, this is the black line. Let's rework that. This is the black line. The area that's above the black line, below the red line, and above the green line is shaded right here. If you're going to do the next question and find out whether or not it's a function, then you have to do this thing. Remember, it's a thing called the vertical line test, and so you just take a vertical line and you imagine a vertical line going across the picture. It doesn't touch it in 2 places. So yes, it's a function. So you just circle yes. Yes, it's a function. Yes, it's 1-to-1, because when you do the horizontal line test, remember the horizontal line test really and truly is to see if the inverse is a function, but we're using it to help us decide whether something's 1-to-1, so it's yes. The domain is what it could they be, and we write all real numbers. Remember, the way we state all real numbers has changed to negative infinity, positive infinity. That's the way we say all real numbers now, using interval notation. So again, the range can be anything. There's no numbers that it can't be. It doesn't get to a certain point and stop or anything. The end behavior, you just look, says that as the x approach, as x gets bigger and bigger, y is going up. And how do we say up? We say y approaches positive infinity. And then how do you say something goes, as x approaches positive infinity, you say y goes down. And how do you say y goes down? You say y approaches negative infinity. Remember, that's how you say right. This is how you say right. This is how you say left. This is how you say up. This is how you say down. This has none. It doesn't make any sense that it has intervals of increase, because it's always decreasing. Okay. Again, always is negative infinity, positive infinity. X-intercepts is where it crosses the x-axis. There's x-axis, negative 7, 0. Y-intercept, we just look at the y-intercept. Where's it crossing the y? At 0, negative 6. Anything crosses the y-intercept, you just write the coordinates of it, and this thing has no asymptotes because there's no line. It's getting closer and closer and closer to, but never touching. So there's 30 and 31. Let's do the same thing for 32. Again, notice the function. Yes, it's a function. Horizontal line, yes, it's 1-to-1. Remember, it's before you say no on 1-to-1, it's got to be something like this. And before you say no on a function, it's got to be something like that. That would be no on a function. This would be yes on a function, but no on 1-to-1, because this horizontal, it fails the horizontal line test. But this particular picture here is yes and yes. The domain, again, the domain could be anything. Notice the x's. It could be any x value. It could be over here at 10. It'd be hard. You'd have to go way down there. but it can get there. Uh, the domain then is all real numbers, negative infinity, positive infinity. Notice that this thing, whatever this equation is, and you should recognize this, is an exponential. Look, it's an exponential growth that's been flipped. It's got a negative. It should be going right through there, so it must be negative 2 times 2 to the x. Okay, so the range, I notice the range is never up here. There's no y values up here. All the y's are below 0. So I put in negative infinity, 0. Oh, that looks like an 8. I kind of didn't do it on its side the way I should have. There we go. Not 8, negative infinity. The end behavior, as x approaches negative infinity, y is approaching 0. As x approaches positive, as x is going to positive infinity, y is going down negative infinity here. Again, this is, when is it increasing? Look, it's never increasing, so it doesn't make sense. It's always decreasing. So this doesn't have an interval of increase. It only has an interval of decrease. It does have an asymptote. That question must be here somewhere, so let's go with here with the asymptote. Y equals 0, because that's the line that this thing gets closer and closer and closer to, but never touches. So it'll be y equals 0. This is y is less than 0. But we write it in interval notation that way.